5379. In what ways do advection fog, radiation fog, and steam fog differ in their formation or location? A. Radiation fog is restricted to land areas. Advection fog is most common along coastal areas. Steam fog forms over a water surface. B. Advection fog deepens as wind speed increases up to 20 knots. Steam fog requires calm or very light wind. Radiation fog forms when the ground or water cools the air by radiation. C. Steam fog forms from moist air moving over a colder surface. Advection fog requires cold air over a warmer surface. Radiation fog is produced by radiational cooling of the ground. The correct answer is A. Radiation fog is restricted to land areas because water surfaces cool little from nighttime radiation. Advection fog is most common along coastal areas but often develops deep in continental areas. Steam fog, also known as sea smoke, forms in the winter when cold, dry air passes from land areas over comparatively warm ocean waters. 5380. With respect to advection fog, which statement is true? A. It is slow to develop and dissipates quite rapidly. B. It forms almost exclusively at night or near daybreak. C. It can appear suddenly during day or night, and it is more persistent than radiation fog. The correct answer is C. Advection fog is a type of fog that forms when warm, moist air moves over a cold surface. The warm air is cooled by the cold surface, and the water vapor in the air condenses, forming fog. Advection fog can form at any time of day or night, but it is most common in the morning and evening when the temperature difference between the warm and cold air is greatest. Advection fog can be persistent, lasting for several hours or even days. It is more persistent than radiation fog, which forms when the ground or water cools by radiation at night. 5351. What is an important characteristic of wind shear? A. It is present at only lower levels and exists in a horizontal direction. B. It is present at any level and exists in only a vertical direction. C. It can be present at any level and can exist in both a horizontal and vertical direction. The correct answer is C. Wind shear is a sudden change in wind speed or direction. It can be a hazard to aircraft, especially during takeoff and landing. Causes include fronts, mountains, and thunderstorms. Pilots should listen to weather briefings, check radar, be aware of the environment, fly at a safe altitude, and be prepared to take corrective action. 5449. The Low-Level Wind Shear Alert System, LLWAS, provides wind data and software process to detect the presence of a rotating column of air extending from a cumulonimbus cloud. B. Change in wind direction and/or speed within a very short distance above the airport. C. Downward motion of the air associated with continuous winds blowing with an easterly component due to the rotation of the Earth. The correct answer is B. The Low-Level Wind Shear Alert System, LLWAS, is a ground-based system that uses sensors to detect wind shear near airports. Wind shear is a sudden change in wind speed or direction that can occur at any level, but is most dangerous during takeoff and landing. LLWAS systems can detect wind shear up to 3 miles from the airport and up to 1,000 feet above the ground. LLWAS systems use a variety of sensors to detect wind shear, including anemometers. Anemometers measure wind speed and direction. Acoustic sensors. Acoustic sensors detect changes in wind speed and direction by measuring the sound waves created by the wind. Radar sensors. Radar sensors can detect wind shear by measuring the Doppler shift of the radar signal. LLWAS systems use the data from these sensors to create a real-time map of wind shear conditions near the airport. This information is then used to warn pilots and air traffic controllers of potential wind shear hazards. LLWAS systems have been shown to be effective in reducing the number of accidents caused by wind shear. In the United States, LLWAS systems have been credited with preventing over 100 accidents and saving over 1,000 lives. 5352. Hazardous wind shear is commonly encountered. A. Near warm or stationary frontal activity. B. When the wind velocity is stronger than 35 knots. C. In areas of temperature inversion and near thunderstorms. The correct answer is C. Wind shear is commonly encountered in areas of temperature inversion and near thunderstorms. Temperature inversions can trap pollutants and cause poor air quality, while thunderstorms produce strong updrafts and downdrafts that can result in sudden changes in wind speed and direction. Wind shear poses a serious hazard to aircraft, especially during takeoff and landing. Pilots should listen to weather briefings, check radar, be aware of the environment, fly at a safe altitude, and be prepared to take corrective action.